Hello, my name is Jupiter Hadley, and let me introduce you to the unofficial Game Maker Meetup, a monthly meetup event where we have talks around the many aspects of game development in general, as well as with Game Maker Studio, along with casual discussions and socializing with game developers. The meetup is organized and run in our spare time by Quang DX of Asobi Tech, Juju Adams, and myself, Jupiter Hadley. More info can be found on Twitter at GMMeetup or Facebook on the unofficial Game Maker Meetup group. Here's one of our wonderful talks.
Cool. Right. Without further ado, Ross.
Hello everyone. Today I'm going to be talking about multiplayer games in Game Maker Studio 2 and networking and protocol design and how you can do that in your own game. Firstly, a little bit about me. I'm Ross. Hi.
Hi, Ross.
I'm a software engineer and I make games sometimes. So I started doing game stuff in general when I was about 8, and I tried to make a platformer in PowerPoint. I've been doing stuff since then. I somewhat succeeded with that. I figured out how to make those sort of maze games where you move the mouse around and there's all sorts of traps and things, and did a bit more with PowerPoint. But you can't use the keyboard. So I started doing modding for Pokemon games and still found that limiting because it's Pokemon and you can't really do much outside of Pokemon if you're modding a Pokemon game. So I picked up Game Maker, which was about version 6 at the time. I was 12 years old. I had an IT teacher as a tutor in my secondary school, and she was doing this for an old year group, and during one of the tutor times she spent 5 minutes just showing me how to make a ball bounce around and score points when you click on it. And that was about the only tuition I got on Game Maker. After that I just started making stuff and I got addicted to it, and I made all sorts of things on the Game Maker sandbox, which doesn't exist anymore, but you can find stuff in the archive. I started doing Java when I was about 15, got into Minecraft modding, and got into Minecraft roleplay communities. So I once tried to code the entirety of the D&D 3.5 Players Handbook into a Minecraft mod. I've written world generators and interesting stuff with that. I currently maintain a suite of plugins to run roleplay servers. So if you're running a Minecraft roleplay server, talk to me, I can help you out. I started doing game jams when I was about 16 with Lumdare 24. It was Evolution, and I used Game Maker for that. I've since started doing game jams in real life locations and meeting people through that. Started with a global game jam in about 2014. And I've been around Guildford, Oxford, London, and I know a lot of people in the indie scenes there now. At 18, I got my first professional programming job at a big technical consultancy. I did most of my work in the public sector, and I can't talk about a lot of it. After a couple of years of bouncing between QA and dev stuff there, I burned out pretty hard, and I left to do freelance work for about a year to just try and make ends meet while having the space and time to rest and be able to do things again. Then I started working at OpenBet, where I now work. Well, it's become SG Digital now. And I work on sports betting software. I am now also working on a game called You Yourself, which is a minimalist abstract game about introspection and finding who you are. It might come out at some point, hopefully. So this talk is about writing online multiplayer games from a technical perspective. It doesn't cover topics like community management or getting an audience in the first place, but they're also super important, so do pay attention to those. This is intended to be an overview. I'm not going to talk about many of the intricacies of scaling up or databases, and although those are important for a full multiplayer game, there's a lot of topics to cover, and I'm going to just give a broad overview of everything that you need to know just to get stuff running. If you're interested in scaling things up a lot more, then I can talk to you about things like Kafka and JMS and message queues and more complex stuff. Just ask me questions whenever. I'll fill you in on the background knowledge required for this. There's some pieces like how to read binary and buffers and stuff like that. Just bits of technical knowledge that you might not necessarily know unless you have a technical background. Most of this is around A-level computing stuff. I'll try and make it approachable. If anything is not very understandable at any point, just say and I'll try and explain it better. So I'm going to cover packets, how they work, network design, how different types of networks work well for different types of games, protocol design, why it's important, and how to design it for your game. All right, so why online multiplayer? The biggest reason is playing with friends is fun. And most of our friends at this point seem to end up on the other end of the world. And if you want to play with friends that are on the other side of the world, then you need to do it online. Games can also help us make new friends. There are lots of gaming communities where I've met people that I wouldn't have done otherwise, and lots of people from different cultures and different places. We can learn communication skills if we're heavily introverted, and it's easier to do when you're not speaking to someone face-to-face. There's a lot of stuff that we can learn through that. Lastly, other players are more interesting to play against than AI components because they're less predictable, and they can do things that you wouldn't necessarily expect in a game. All right, so when, during the design of your game, should you think about adding online multiplayer? Design around it if possible. Like, if you're making an online multiplayer game, think about it from the offset if you can. It's much harder to add it in later than it is to design around it early. If you're adding it to a game that's already got single player, there's a lot of code that you've already built up that you're going to have to work around. You're going to have to shoehorn in a lot of the multiplayer stuff, and it'll end up with something that's not as pretty. If single player comes first, but you definitely want to add online multiplayer, then consider making the game as a server with the single player client connecting into it, because it will be easier to add stuff on top of it later. If this is your first game, don't try doing multiplayer. It is not trivial, and you will come across a lot of problems in addition to the problems that you'll come across when you're doing your first games. If you've done a few games before, then the problems that you've already seen, you will be able to solve quicker, and they won't be as much of a problem. So you'll be able to just be focusing on the problems that are specific to multiplayer games. Yeah, so make sure you know how to solve basic problems first. All right. So how do I go about designing a game with multiplayer? Plan is the one piece of advice you should definitely take away. Spreadsheets are really important. You'll have a lot of these for different pieces of information. Your protocol will probably be the most interesting one, especially when it gets more and more complicated. There'll be a lot of stuff in there and lots of different packet types, and that spreadsheet will be very important. Keep track of them. Like, spreadsheets can get everywhere. Think about what's important for your game when you're planning. What time delay on actions is acceptable? Different games will have a different answer to that. If you've got a turn-based game, it might be slower than something that is very focused on real time. Think about how people play the game. Is it cooperative? Is it competitive? do people compete against other players? Do you need to do any prediction client side? This can make gameplay smoother, so for things that are in real time, it's often a must, because otherwise things get really jittery and it's not very pleasant. How is the game set up? What information does a player need to join? Can they just go in with a username? Do you need to have identity verification for every player? Do you need any sort of information around the player? Also think about whether you need a chat. Having a chat system in a multiplayer game means that you have to think about moderation. And different games have different solutions to that. Battlerite notably has the chat disabled when you start playing it. Dota has an awful chat and is especially bad for non-male sounding folks. Guild Wars has a friendly community. The game is designed about being cooperative, but they still have things in place like filtering of chat that you can set yourself. All right, so background knowledge that you're going to need to know for technical stuff. The numbering system you know is called denary. This is a base 10 number system in that every time you reach 10, you increment the next number to its left. Binary is a base 2 number system, so every time you reach 2, it increments the number to its left. So for each number from the right, in denary, you'll increase in powers of 10. In binary, you'll increase in powers of 2. So the value of each number will be higher in different increments. Binary, each digit can only be a 0 or 1. Denary, it can be 0 through 9. In binary, it's easier to represent on the machine as it's represented as a 0 volts or 5 volts charge on the wire. Numbers are often represented in hexadecimal as well, so it's often good to read stuff about that if you're going to be reading a lot of documentation, because it's quicker to convert to and from binary, and it's shorter to write. Hex is a base 16 number system, so you have 0 through 9 and then A through F. It's important to note how many binary digits a number is going to take up, especially if it's being transferred over the network frequently, because especially if the game is run on mobile or web as well, because it might be run over a mobile data connection. Yeah, this will use more of your network bandwidth if you have frequently sent packets with big bits of information. A quick bit about buffers. Buffers are areas of memory on the computer. You allocate them to store data, and you can queue up pieces of data into the buffer of different types and then read out the data again later. Buffers, when you're writing networked games, are used to queue up the data you want to transmit. I'll talk a bit more about that later. Buffers are allocated at a certain size. While most of the time you know the size of the packets you're going to be sending, especially if it's a lot of numbers, sometimes you don't. If there's string data like text, it can vary in size, so you need to use a dynamically allocated buffer, which in GameMaker uses a type called buffer grow. When you put stuff into your buffer, the buffer will increase to accommodate that. There's a few buffer-related functions. Remember to delete your buffers afterwards, otherwise you end up with memory leaks. Other than that, most of them are relatively self-explanatory in creation and writing to a buffer. Okay, so data types. There are various different data types. GameMaker has a set of data types which it uses in most of the engine, And then it has a set of data types which it uses in buffers, which are slightly different because in buffers, the amount of data a number might take up is different based on how much accuracy, on how big the number can be, and other factors. So the types of data in GameMaker that you tend to write to a buffer include strings, reals, and booleans. Strings include text data. Each character takes up a byte. I believe GameMaker is UTF-8 encoded by default. So each character in the string will add another byte to the size of your packet. Different numbers will take up different sizes. Floating point numbers are different to integers as well. If you need to have fractional data, you need to use a type like F16, F8, etc. There are a few types that are for unsigned integers and a few types for signed integers. Unsigned integers allow you to go higher with the same amount of space in the buffer being used, but they don't support negative numbers. There's also a few more. So there's two different text types in buffers. There's buffer string and buffer text. Buffer string includes a null terminator. Buffer text does not. If you are writing buffer text over a network, so that the other side knows how long the string is, you need to send the string length before the string comes through. With a string, you can keep on reading until there's a null terminator. They both take up the same amount of space in the buffer because it's either a byte for the null terminator or a byte for the length of the string. So it's mostly down to personal preference and how you want to read the data on the other end. But there's a few quirks around how to read them. Packets. So packets are also called frames, in case you're reading any documentation that refers to them as frames. A packet usually contains data about one action. You will have a set of client-bound packets and a set of server-bound packets. And multiple packets can be sent in one flush. So your protocol will define how big each packet is and what data is in there. If you send multiple packets in one flush of data, then the other side will just receive it as one stream, and you'll need to know to break it up on that. Packets are made up of different types. Generally, each packet can be considered a collection of fields, of which the context is apparent by understanding the protocol. The client and the server understand the packets based on ordering and length information, and can relate information back to the things in your game when receiving a packet. You need to design a set of packet types for the protocol. And the server and the client both need the information on both client-bound and server-bound packets so they know what to write and what to read. So if you come from a web development background, you might be used to seeing data like this, or in XML if you've been around a long time. This has a lot of stuff that we don't necessarily need. This is human readable and gives data context, but and we could just JSON encode, JSON decode, and write that as a string to your buffer. But there are a few reasons why we don't do this. Games are high throughput, so if you're writing a JSON string like this into a buffer, that's going to be, this is, for example, a position update packet. This is going to be 50 bytes every position update because you're writing every character in the JSON string into your buffer. If we remove everything unnecessary, we can shorten this to 4 bytes. Because the client and the server both know the context of the data, so we don't need to include the field names. We don't need to include any of that because we don't need to read the packets. The client and the server can make sense of their data themselves because of what they know about what data they're going to be receiving. So they can relate each bit of the packet back to the fields it's going to update and what's going to happen. So you can do any logging on the client or the server. You don't need to include it in what you're sending. But it's less data being sent. So again, especially in mobile games, this is important because it will use up mobile data and it will be faster to send. This is mostly the importance of protocol design, making sure the client and the server both understand what is being sent by the other, and making sure there's as little excess as possible, especially on the packets you're going to send very frequently. So designing a protocol. This was usually done in an Excel sheet. You can either write them in columns or rows, depending on your preference. I would usually do them in rows because that's easier for me to read. You'll have a packet identifier for each packet, which will tell you what sort of data you're expecting. And then within that packet, write out each of the fields that you're going to have and what data type it is, so that you know what to write or read into that. You always have a version packet. It's 2018, you're going to update your game at some point. You're probably going to want to update your protocol as well. If you have a version packet, then you know what version of the protocol you're operating on, and you can immediately notify the player if they're running an outdated version of the client or if they're trying to connect to an outdated server. You will get smarter the more you work on your game, so you'll want to change things. Think about the player authentication and how you're going to handle that. You might be using a platform like Itch or Steam or something where the authentication will be handled mostly for you. You can interface with that. It will have some specific data to the platform. You might want to do your own auth if you're running stuff off your own servers and want to authenticate people with, I don't know, a forum account or something. Assign players IDs. Don't use player names because they're bigger and they can change. So whenever a player is connecting to the server, usually have a player ID for the session associated with the channel that you're communicating with them on, and you can use to communicate with them. Write out all the possible things that need to update during gameplay. Assign each of the actions an identifier, and decide which data type is used for each field of that action. Yeah, and keep your client-bound and server-bound packets separate. Don't have one list of all of them, because this can get confusing for both. There might be extra data needed on one side or the other. Often, if you're updating something about the client you're sending something from, you won't need to include the client, for example, because the server will know which address it's coming from, which channel it's coming in on. All right, so there's a few different types of networks that games can operate on. A LAN is a local area network. This is the network that is behind your router, like a home network sort of thing. A MAN is a metropolitan area network, but most people don't care about that anymore. And a WAN is a wide area network, like the internet. The local area network's the smallest, and you will have IP addresses within there that start with 192.168. Those aren't accessible externally. You might have 10.1 addresses if you have a different type of network configuration. They're local to your network. It'll work fine for a LAN party or something if you have a server hosted within that network, but it won't work if you want people over the internet to connect. Wide area networks, WANs are global scale, and each device and LAN connected to the WAN has an address on the WAN. When an incoming connection comes to your LAN, the router may then do something called port forwarding, where it routes the port, which is included in the packet header, and is a number between 0 and 65,535, to a machine within your LAN. based on the configuration you set up in your router. The machine will then direct that incoming connection to an application listening on that port on your machine. Many ports are standardized, such as 18.443 for HTTP traffic, 22 for SSH, 21 for FTP, etc. So you'll probably want to pick one that's not used often in the upper ranges, which will be something usually with 5 digits, something in the 30,000s, 40,000s, etc. Because then it won't be conflicting with any other applications that are running on the computer. There are different types of network configuration that you might want to consider for your game. First type is having a server embedded within the client. This allows a client to act as the host. They connect back to the server that is inside the client, and other clients also connect to that server. There are multiple ways to set this up. The first is having the player with the server embedded in the client forward the port that's required for the server to run on. This is easier from your perspective to write, but it's not as easy for players because they have to understand how their router works and how the configuration to that works. The second type is something called NAT hole punching, which creates a hole in your firewall by the client connecting to an external server in order to open a port as a client port. Client ports are randomly decided based on free ports in the range, usually in the upper ranges, decided on your computer when something tries to connect to a server, and you then use this for each client to connect back into the client. So the client, from the perspective of the firewall, it doesn't think it's acting as a server, but it's opened a client port. The other clients connect back to it as a server through that client port. So that's easier for players because they don't have to do any configuration on their router. They can just get up and play a game with their friends because it just runs. Types of games, including an embedded server, include games like Stellaris, Risk of Rain, and Portal 2. You can write a separate piece of server software, which can serve multiple clients. You can either host this as a service for your game, which will run during the game's lifetime, but this includes an additional cost on you, or you can distribute that piece of software to other people, which reduces the control you have over that, but allows people to do interesting things with your server. It's designed, if it's designed for multiple smaller communities to grow inside it, you may want to do that. It has the additional benefit of easier server-side modding. People can make changes to your server and do exciting things with your game. And allows people to produce more unique content. This also means players hosting tend to have significant technical expertise. They'll be more familiar with things like port forwarding because they're running a dedicated server for their community. If you're hosting the server yourself, players don't have to do any setup at all, so again, it's easier on the player's side. Games that have their own standalone servers that they distribute include Counter-Strike, Garry's Mod, Quake, and Minecraft. Examples of games that host their own servers include Dota, PUBG, Fortnite, Guild Wars, and Splatoon. Just going to quickly mention peer-to-peer networks. Don't do this. People often think that they're going to be easier because the load is bared across all the clients, but it ends up being a nightmare to program. There are a lot of weird quirks that will come up, and GameMaker doesn't have great support for this type of network. Its functions are designed around creating a server and for connecting to servers. So it doesn't really matter where you put your server, but as long as there is a server, it's a bit easier to work with. So setting up the connection depends on your how your network is laid out and whether everything will be using GameMaker. You might decide to write a server in a different language because it will be a higher performance thing. It needs to host a lot more players. If you use the functions ending in raw, data is transmitted as streams without any extra data. It's more easily handled by other languages, and you can choose how you pass it. If you use the functions that don't end in raw, then the type and length of each piece of data will be transmitted in a GameMaker Studio compatible way. So if your server and client are both written in GameMaker, this might be easier to work with. When data is received on either side, GameMaker will fire an event called the async network event. When the client connects to the server or when data is received, it will fire different types of event, and you'll be able to find which type it is in the type parameter of the async load DS map. The DS map includes all of the information about the connection that's taking place, the data that's being transferred. You can read all of that from async load. Async load is temporary to that event. So if you want any data from that, then you need to store it when that event is happening in an instance local variable or in a global variable or something like that. You can send a buffer either as a packet or as raw data. As with the creation of sockets, not using the raw functions includes some GM-specific data. You first write all your data to the buffer, and then you send that as a packet. The buffer's passed, or the buffer ID, which is returned from buffer create, is passed into the packet sending functions, network send. There's a network data type event that is fired when data is received. If your server is not written in GameMaker, use network send raw, and data should be read in the same size and types and order they were written to the buffer in GameMaker. Different languages will have different types for different sizes of data. GameMaker just has real to handle stuff internally, but other languages do have more type safety around sizes of numbers. Servers should generally be as authoritative as possible. That means they take the bulk of the load and they don't generally trust the clients. If a client sends something, then they could be playing with it on their end. If it's a real-time game, then the client can predict what should be happening based on the data it has. This is less important if your game is not dependent on being real-time. So if you're writing something that is turn-based, then it can wait until it has the complete data from the server rather than trying to do predictions. And it can lock all other players from making a move while that's happening. There'll always be a balance between latency and how much the client has to do. The ideal is that players send controls, the server renders what each player sees and sends it back without delay, but this is more or less impossible because of latency. Clients do rendering themselves to reduce the load a little bit and can predict stuff in advance. So the server takes on the processing and then sends what it's done back after it's finished processing, so the client can update the renders later. There's a few quirks that GameMaker has that you should know about if you're writing any of the other stuff in anything that's not GameMaker. Specifically, numbers are sent in little endian, so it's not the same as the default in many other networking libraries. You may need to configure them to accept little endian. Little endian reads numbers in the opposite order to big endian. So you'll start reading the ones and zeros from the opposite end, and you'll end up with a different number. So you might end up with some weird numbers if you're reading the wrong numbers, reading in the wrong endian. So it's easy to spot if you know it's going to come up. If you don't use the raw functions, headers will be sent through, which can confuse your other piece of software. You'll notice that you're getting a lot of extraneous data if you're doing that. You can do stuff to handle that, but it's a lot easier just to use the raw functions. Numbers in GameMaker are all just considered reals, so their type is taken from how they're written to the buffer. Other languages do have types to handle different types of numbers. And that's all. Are there any questions?
games written with peer-to-peer networking?
Not that I know of. There's definitely not in GameMaker that I know of. There's probably something out there.
And it's a mess, right?
Hmm?
And it's a mess, I guess.
Yeah.
Have you ever implemented WebSockets in HTML5 specifically?
Yes. Yeah. A while ago, I think it was Global Game Jam at Newspeak. I did that thing with, I did a game which was room scale multiplayer. Everybody connected with their phones, and WebSockets ran on the phone to send data into the game, which would do all of the rendering as the game. So it was running a WebSocket client which connected into the game, and then the game did all of the processing on that side and did the rendering on the end.
Is that in GameMaker?
That wasn't in GameMaker.
Okay.
That was a huge polyglot of different languages and stuff.
I have a question. The functions that you showed us in GameMaker, they use like TCP or UDP for the packets themselves?
There's a parameter that's passed to them. There are different functions, I believe, for UDP and TCP. So you can do stuff with UDP and TCP.
Okay. Yeah, so, I mean, you can also handle the ordering of packets by your own if you need to, when you use UDP, for example. Okay. Yeah. Thanks.
Yeah, just to clarify, does everyone know what TCP and UDP are, what the difference is between them? Does anyone not know?
For the benefit of people at home.
Okay, all right. So TCP, the connection is guaranteed. Client packets are always guaranteed to be received. UDP packets might come in any order and they might not get there at all. So it's good for things like time data or bits of information that don't really matter too much, maybe aesthetic things a lot of the time. TCP will be guaranteed in order and that they will actually arrive.
Cool. Thank you very much, Ross.
Okay.